vectors. We're starting with a definition. A vector is a quantity that is determined by its magnitude and direction, whereas a scalar is a quantity with magnitude but no direction. Now, a zero vector is a vector whose magnitude is 0 and whose direction is not defined. It is usually written in bold as the 0. Now, two vectors are equal if they have the same magnitude, A equals B, or in the same direction, A equals B. The negative of a vector V is the vector with the same magnitude but opposite direction. Now, the scalar multiple of a vector, let K be a scalar and V be a vector, then the scalar multiple KV of V is the vector multiplied by that scalar, whose magnitude is K times the magnitude of the vector. So it's this, that has the same direction as V if K is greater than 0, and opposite direction if 0 is greater than K. If K equals 0, then K of V equals 0. Now, the triangle law for addition of vectors. The sum P plus Q of two vectors P and Q is obtained as follows. 1. Starting at a point, draw a vector P. Starting from the tip of the vector P, draw a vector Q. Then the sum P plus Q is the vector from the tail of P to the tip of Q. Now, I'll show below the parallelogram law for addition. The sum P plus K of two vectors P and K is obtained as follows. 1. Starting at the same point, draw the vectors P and Q. 2. Complete the parallelogram of which these vectors are adjacent sides. So the sum P plus Q is the vector from the point where the tails of P and Q meet to the opposite corner of the parallelogram. I'm always going to struggle with that word, which once we've drawn it is here, which should clarify what I'm talking about. Now, the properties of vector algebra. Let P, Q and R be vectors. Let A and B be contained in R, our reals. The following properties hold. Commutativity. P plus Q equals Q plus P. Associativity. P plus Q plus R. P plus Q plus R. And distributivity here. And subtraction, the difference, P minus Q of the vectors P and Q is P minus Q, P plus minus Q. Our components of a vector in R squared, which is our reals plane, the vectors I, J are unit vectors in positive direction of X and the Y axis. In R3, our cubic volume, should I say, elements, volume elements I, J, K, and our unit vectors in X, Y, and Z direction. So an example here in our two-dimensional, 3i plus 4j. This is 3i across 4j up, and this is our vector. Our unit vector is given here. Our I and J, how it's defined, 1 over the magnitude of V multiplied by V. That's our unit vector. So here we're going to give an example where there's some trigonometry involved. So V is at the point 9, 3, and U is at the point 4, minus 2. So about the x-axis, the reflections about the x-axis or rotations. So, yeah, pretty much. We find the angle theta. U dot V. From our dot product, we get 4 multiplied by 9 plus minus 2 multiplied by 3 equals 36 minus 6 equals 30. So U, our magnitudes, we're plugging in, we get 2 root 5. And likewise for our V, we get 3 root 10. So our cosine is U dot V over our magnitudes of them. So it's 30 over these for what we've just got here for our magnitudes, which equals 30 over 30 root 2, or equals 1 over root 2. Hence, theta equals the inverse cosine of 1 over root 2, so it equals pi over 4. And that's the angle here, which we were asked to find. Now, normal vectors. A normal vector is perpendicular to the plane, as demonstrated here, and it's usually denoted n, n of a, b and c. So our p is x1, y1 or z1, and our x, x, y, z, and so on. And the normal is just basically the one pointing out of the plane. Now here's an example. Determine the equation of the plane in R3, our volume, should I say, that contains the point 1, minus 1, 4, and as a vector 2, minus 2, 3 as a normal equation, and the equation of the plane x dot n equals p dot n, where x is x, y, z, and p equals 1, minus 1, 4, and n, this is our normal here. So if you plug these values in here, we get this 2x minus 2y plus 3z, and we're plugging in all the numeric values, so we get 2x minus 2y 3z equals 16, and that's the equation of the plane that contains these points. And that's it. I think that's vectors. Please do like and subscribe.